Okay, so you've probably heard this idea before, right? That you basically have two brains. There's the fast, emotional, gut instinct one, and then there's the slow, logical, rational one. And they're supposedly in this constant battle inside your head. It's a great story, but is it what the science really says? Let's dig in.
So this whole idea is based on what's called dual process theory. It basically splits our thinking into two categories. You've got your type 1 thinking, that's your gut reaction. It's super fast, totally automatic, you don't even have to try. And then there's type 2. That's the kind of thinking you have to consciously turn on, for a hard math problem or something. It's slow and it takes real effort.
Now, the star witness for this whole theory, especially when it comes to morality, is the famous trolley problem. It's held up as the classic example of these two systems going head-to-head. Psychologists even have a name for it, the moral dual process model.
Okay, let's quickly look at the two big scenarios. First, you've got the switch dilemma. A trolley is about to kill 5 people. You can pull a switch, divert it, and it'll only kill 1 person instead. Most people say, yep, pull the switch. But then there's the footbridge dilemma. Same trolley, same 5 people. But this time you have to physically push a large person off a bridge to stop it. Here, most people say, no way. Same outcome, right? Save 5, sacrifice 1, but the answers are completely different. So what gives?
Well, the theory gives us a really tidy answer. It says our fast, emotional brain recoils at the horror of pushing someone. But our slow, rational brain, it just does the cold heart math. 5 lives are worth more than 1. This kind of outcome-focused thinking is called a consequentialist judgment. And the theory's big prediction is that if you can just get people to use that rational brain, they should be way more willing to push the person. It's a simple, powerful idea.
So, for decades, this has been a central idea in moral psychology. Researchers have run countless studies trying to prove it. But what happens when you take all of that evidence from all of those studies and put it all together? Does this elegant theory actually hold water?
And here, my friends, is the plot twist. A massive new analysis put this whole theory to the ultimate test. They gathered up all the data they could possibly find, and the results were definitely not what anyone expected.
And look, we're not talking about some small one-off study here. This was a meta-analysis, a study of studies. It pooled the results from 68 different experiments involving a staggering 14,003 people. This is about as good a look at the real-world evidence as you can possibly get.
And here it is. This chart says it all. See that big bar on the left? That's the huge effect the theory predicted we'd see when people use their rational brain. Now, look at the tiny little sliver on the right. That's the effect researchers actually found across all those thousands of people. The real-world effect was incredibly, incredibly small.
So the bottom line is this. The meta-analysis found that the effect of nudging our rational brain is so small, it's basically zero. The core evidence for this really popular model, it turns out to be surprisingly weak.
Now, this is a really big deal. It suggests that this simple story of an emotional brain fighting a rational one, it might just be wrong. So if that's not what's happening inside our heads, is there a better, more accurate way to think about how we think? All right, let's follow a new lead. Because instead of just using these moral dilemmas, some scientists are now using some pretty amazing technology to get a direct look at how much effort our brain is putting in, moment by moment.
This technique is called pupillometry, and it's based on this wild fact. The harder your brain is working, the wider your pupils get. So by tracking the size of your pupils, we can literally see your cognitive effort in real time. It's like a direct window into how hard your brain is working. How cool is that?
So here's how a study like this works. They give someone a complex card matching puzzle. The trick is, the hidden rule for how to match the cards keeps changing, so you have to figure it out by trial and error. And the whole time you're doing this, a camera is precisely measuring your pupil size.
And what this new technique has revealed is that maybe it's not a battle between fast and slow. Maybe it's a dynamic balance between two totally different modes of thinking, exploration and exploitation.
Let's break that down. Exploration is what you do when you have no idea what the answer is. You're searching, you're looking for new information, you're trying to discover a pattern. There's a lot of uncertainty. Exploitation is the opposite. That's what you do after you've found a rule that works. You're just applying the strategy you already know. Uncertainty is low, and it's all about being efficient.
So check this out. Here's the first incredible finding from the study. When people were in that exploration mode, searching, feeling uncertain, trying to find that new card rule, their pupils consistently got bigger. It's a sign of a heightened state of arousal in the brain.
And then, the moment they figured out the rule, the instant they switched to just applying it to exploiting that knowledge, their pupils got smaller. It's a clear physical signal that the brain has literally switched gears from discovery to just getting the job done.
I mean, think about what this means. Our pupils are giving us a direct physical signature for two completely different cognitive states. Exploration is this steady state of high alert, ready for anything. But exploitation is more focused. Your brain just dials the effort up or down depending on how hard the task is.
Okay, so when we put all of this together, the big meta-analysis and this new pupillometry stuff, what's the final verdict?
Well, first, that really popular story about an emotional brain at war with a rational one. The large-scale evidence just doesn't seem to back it up. It's a great story for sure, but it's probably too simple to be true. Instead, what the neuroscience is showing us is a picture of a much more flexible brain. It's not about a fight. It's about a brain that's constantly and dynamically balancing two absolutely essential jobs.
What really seems to be happening is this fluid cycle. Our brain explores the world to find new knowledge. Once we learn something useful, we switch gears to exploit that knowledge so we can act efficiently. It's not an internal conflict. It's a beautiful, dynamic balance.
And that kind of leaves us with a final thought. Imagine if you could watch your own pupils change as you go through your day, learning a new skill, trying to solve a problem. What do you think you'd learn about the moments your brain decides, okay, time to discover something new, versus the moments it says, all right, we know how to do this, let's just get it done?